Okay, welcome back. Now, we have a couple more things to share about the welfare properties. Basically, what I want to define now are two things. First is the concept of envy-freeness, okay? And the second is the concept of fairness, all right? Now, we consider the same economy actually, but now with more than two agents. So we have n different goods and h different households or consumers, okay? And we write utility function this way. Okay, so this is the utility of consumer H. And of course, it depends on the consumption levels of all goods, right? Now, within this setup, and this is again an endowment economy. Okay, so within this setup, we say that an allocation X is envy-free if people obtain the largest utility with their own consumption bundle. Okay, look at this. Now we are comparing two consumers, consumer H and consumer J. All right. Now we are looking at this from the perspective of consumer H. Okay, so consumer H obtains a larger or at least equal utility by consuming his own consumption. Okay, by consuming his own allocated levels. Compared to what? Compared to any other agents. Right? So what does it mean? Let's say I am consumer H. Okay? Under some allocation X, this is the allocation that I am evaluating now. I'm trying to understand whether it is envy-free or not. For this allocation, I have X1H from the first good, X2H from the second good, that goes on, right? XNH from the nth good. Now, I obtain some utility from this by using my utility function, okay? Then, I look at another agent. Let's say I'm looking at Gökalp's. Okay, let's say J is Gökalp. I look at what Gökalp consumes. Now, I evaluate my utility with Gökalp's consumption levels. And if I still prefer myself, right? And if this is true for all agents other than mine, then this is envy-free. So I do not exhibit envy to other people. Okay? So why is that helpful? Because we say if an equilibrium is both Pareto efficient and envy-free, then it is fair. All right? Now, of course, we can discuss whether this is good enough for a definition of fairness. But at least we can formally discuss fairness here, right? Because here, first of all, it is Pareto efficient. So you cannot increase one people's welfare without at least decreasing one people's. And second, everybody is happy with his own, with her own allocation. Nobody is exhibiting envy for other people. So I do not envy, for instance, Jeff Bezos. Betül does not exhibit some envious behavior against my allocation as Aykut. Okay? So every agent in the economy, when he or she evaluates other person's consumption bundle with his or her own utility function, it is still larger than that or at least equal to that. So this is one way of defining fairness. Okay? Because again, it is Pareto efficient and again, it is envy-free. All right? Now, we can now discuss several other things, several examples. For instance, let's imagine this example. Let me share my screen. Sorry, stop sharing my screen. Okay. Now imagine this. Let's say this is an economy of 6 people, right? Right now we are 6 people here. Betül, Oğuzhan, Abdullah, Aykut, Attar, and Gökhan. Now imagine that this is an endowment economy, and imagine that there is only one good. Imagine cookies, and cookies are distributed to us. Let's say I have 3 cookies, Betül have 2 cookies, Oğuzhan have 5 cookies, Abdullah has 75 cookies, Aykut Kutlu has 1 cookie, and Gökalp has 0. Okay. Now the question is this: is this allocation Pareto efficient? And of course, we assume that we are obtaining utility by consuming cookies, right? And nothing else. Now, is this allocation Pareto efficient?
I think not.
You think not? Why not?
Because I have 0 cookies.
Okay.
So I'm envious of the others.
No, I'm not asking for fairness. It's about Pareto efficiency. We're gonna come to that. We're gonna come to fairness as well, but let's discuss. Everybody has some number of cookies, not necessarily equal, and somebody has 0. The question is whether this is Pareto efficient. The answer is yes. Because if we all enjoy eating cookies, now if I redistribute resources, if I take 5 cookies from Abdullah and give these 5 to you, yes, your utility would increase, but Abdullah's utility decreases. Okay? So in that sense, this allocation, without exchange, of course, is not, so it is Pareto efficient. Okay? Now let's discuss another. Let's suppose that there are 2 goods now, not just cookies, but also lemonade. Okay? And suppose that you are the citizens, 5 of you, and I am the dictator. All right? Now we obtain utility both from cookies and from lemonade. Okay? And initially, suppose that everybody has 5 cookies and 1 lemonade, and I have nothing. All right? So you all have 5 cookies and 1 lemonade, and I have nothing. All right? Now, as a dictator, I get all your cookies and I get all your lemonades. All right? So this is an allocation now. So I have 25 cookies and 5 glasses of lemonade. Now, is this Pareto efficient? Here, of course, assume that utility is increasing in both arguments, right? So your utility would be higher if you consume more lemonade. Your utility would be higher if you consume more cookies. And my utility is the same. Now, is this Pareto efficient? The answer is yes. Yes, of course. Why? Because I'm consuming 25 cookies and 5 lemonades. You are consuming nothing. If I want to increase your utility, at least one of you, I still should decrease my utility, right? Now, in general, then, if utility functions are well behaved, and if they increase in both arguments, in all goods, let's say, then there's no production, there's no public good, there's no externality, there's no missing market, there's no asymmetric information, and there's no production. So under these circumstances, in general, any allocation seems to be Pareto efficient, right? As long as we agree, even under dictatorial rules, it is Pareto efficient. Now, obviously, we can do this. Suppose that, another example, suppose that I have 6 lemonades. Okay? I have 6 lemonades, and you all have 4 cookies. Okay, so you all have 4 cookies and no lemonade. And I have 6 glasses of lemonade. Okay. Now we're gonna exchange, right? Obviously, because we all like cookies with lemonade. Okay. So how do we do this exchange? Well, according to our imagine that utility functions are all identical, for instance, for simplicity. Then we're gonna get into exchange because I want to eat some cookies and you want to drink some lemonade. All right, so I will get into exchange with all of you, right? I will require some cookies and I will give you some lemonade for this. So at the end of this scheme, at the end of this trade, again, we're gonna find some price ratios, right? So there will be, so if you want to imagine this, you can actually do this. So, okay, just a sec. So you may imagine that there's a cookie market, right? And there's a lemonade market. So in the lemonade market, there is, of course, some demand, right? And some supply. Supply is equal to 6. In the market for cookies, there's again a demand. And the total amount of cookies in the economy is, you each have 4, so 20 cookies. All right? So you may actually imagine that. If you behave as a single consumer and I behave as a single consumer, right? We have 20 units of cookies and 6 units of lemonade. Okay? And initially, the initial endowment is here. So I have so you have 20 cookies and 0 lemonade. I have 6 glasses of lemonade, but 0 cookies. All right. So I am here, lemonade guy, and you are the cookie guys. Okay. So if this is the initial, we're gonna find somewhere here a Walrasian equilibria. Okay. And that Walrasian equilibria, of course, will be Pareto efficient, right? Now let's be a little bit more specific. Let's suppose that utility functions are same for all agents, okay? And suppose that there is only one good, x, okay? So I is equal to 1. And let's suppose that our initial example. So cookies are, let's say, so the profile is this. x1 is equal to 6, x2 is equal to 7, x3 is equal to 65, x4 is equal to 1, x5 is equal to 0. Okay? Now, we already discussed that this is Pareto efficient, right? Because there's no production, there's only one good. Utility is strictly increasing. Okay? Suppose that your utility function is alpha natural logarithm of x. Okay, alpha greater than 0. All right? So it is strictly increasing, strictly concave. So we already discussed that this is Pareto efficient. Now the question is it fair? Now for fairness, since it is Pareto efficient already, we need envy-free. And for envy-freeness, we need that. First consumer have 6 units, right? So U1 is equal to alpha ln 6. U2 is equal to alpha ln 7. U3 is alpha ln 65. U4 is alpha ln 1, which is 0, right? And U5 is converging to minus infinity, right? Ln 0. Remember, this is the logarithmic function. Right? X ln x. This is 1. This is 0. Now, is it envy-free? What do we require? Now, obviously, U3 is the largest, right? So our third agent does not envy any other. Okay? But the fourth and fifth agents envy the rest of them, right? So we can say in this economy, in this simple example, allocation is not envy-free, right? Because utility functions are the same, right? Because I require this to be true. UH XH greater than equal to UH XJ, right? J is another agent. J is different than H. So in that sense, in this example, it is not envy-free, so it is not fair. Okay? So if you, further imagine another example. Let's now imagine 2 persons and 2 goods. Okay? Now, let's say utility functions are like this. U1 is alpha 1 x1 plus alpha 2 x2. So utilities are linear. Alpha 1 1, alpha 2 1. And U2 is so let me do this. So let's say this is beta. Alpha 1, beta 1. So for the second consumer, I have alpha 2, x1 2, beta 2, x2 2. All right? Alpha 1, beta 1, alpha 2, beta 2, all greater than 0. All right? Now you may imagine different allocations. Let's say allocation A. In this allocation, let's say x11 is equal to 5, x12 is equal to 0, x21 is equal to 0, x22 is equal to 5. Okay? So the first consumer consumes only the first good. The second consumer consumes only the second good. All right? But as you see now, utility functions are different because these parameters are different, right? Alpha 1 is generally different than alpha 2. Beta 1 is generally different than beta 2. So in this model, the situation is a bit different, right? For envy freeness, we require what? We require U1 50 will be greater than U1 05, right? And then we also require U2 05, right? 21 and 22. Sorry. Wait, I have a problem here. So U1 is a function of x11, x21. U2 is a function of x12, x22. So let me do this again. So I have U1, oops, U1, x11 is 5, x21 is 0. This must be greater than or equal to U1, x12, which is 0, x22, which is 5. I must have U2, 0, 5 must be greater than U2, 5, 0. Okay? So this one means the first agent does not envy second agent. This means the second agent does not envy the first agent. And obviously, since these are generally different, this can be true, right? Right? So if you have, so what do we have here? The first condition is 5 alpha 1 plus 0 should be greater than 5, 0 plus 5 beta 1. So if alpha 1 is greater than beta 1, the first consumer is okay. The second condition requires 5 beta 2, right? 0 plus 5 beta 2 greater than or equal to 5 alpha 2 plus 0. So if beta 2 is greater than or equal to alpha 2, right? Then we have fairness, because we have envy freeness and we have Pareto efficiency. Okay? So if utility functions are different, you have to be careful, right? Because I like Coca-Cola, Betül likes Pepsi, so I may not really envy if she has a large amount of Pepsis. Okay? You should be careful with that. I think that's it for today, but let me explain one thing, and after that I will accept your questions and comments. So next week I'm going to show you a toy general equilibrium model with production. I already have a handout for this in the WordPress blog. Okay, but I can upload it to the WHOSM as well. Just look at this toy model, all right? Next week, I'm gonna discuss that, and you're gonna see what it looks like when we introduce production to this simple. So it's a toy model. Why? Because there's one good, one consumer, one firm. Okay. So it is really a toy model, but then of course the similar logic applies to larger economies. Okay. So now I can answer your questions. I can clarify anything that I was not so clear before, and I can hear your comments.
I have no question.
Okay, so you got it all right.
Yes, I hope so.
Good, good. That's good. So if you pay attention, if you read before class, if you pay attention during the class discussion, the material is not that difficult. So it is just notation, but it's a simple thing. I mean, just look at the utility function that I just wrote. It is a linear utility function or a logarithmic utility function. So it's not a big deal. But you must understand the notions. You must understand the concepts, right? Definitions. For instance, fair allocation has a very simple definition, right? An allocation is fair if it is both Pareto efficient and envy-free. Then you should look at the definition of envy-free, right? For an allocation to be envy-free, you evaluate, as a consumer, you evaluate other people's allocations with your own utility function. If you still prefer your own allocation, given your utility function, then you do not exhibit any envious behavior, right, to others. If everybody satisfies that, if everybody is happy with what he or she gets relative to what others get, using his or her own utility function, then it is envy-free. All right? Fundamental theorems are important. We discussed them in the context of Edgeworth-Box, but they apply to larger economies, obviously. That I could give you some exam questions from real-world issues for discussing these theorems. Read the textbook, and if necessary, you can go check your public economics lecture notes, etc. So be free with your, spare time that you spend to this class. So you can read stuff, you can watch stuff. I do not always have to indicate where they are. So it depends on your interests as well. But the idea is simple. First, there is the first theorem, which says competitive equilibrium or Walrasian equilibrium are Pareto efficient. Then second, you may still prefer the economy to move to a different Pareto efficient equilibrium, and you can do it by initially redistributing endowments using taxes and transfers. Okay. Now we have time, about 5 minutes, so we can discuss your questions and comments again. If you do not have anything, that's all for today. Okay, everybody is happy. Gökalp is not happy because he has 0 cookies.
Yeah.
Gökalp, it was just an example, so you can, I can, if you send me your address, I can order you some cookies. All right, but dictator example is important. Sometimes people get confused. With a dictator, you can get Pareto efficiency, you can get envy freeness. All right, it all depends on fundamentals. It all depends on what is the preferences of the dictator, what are the preferences of the public. Okay.
It was tricky, by the way.
It's a bit tricky, yes. Think about the definition, all right? And in general, again, here's the remark. In general, in economies without production, usually we get Pareto efficiency from any equilibrium outcome, right? Because there are no externalities, there are no missing markets, there are no public goods, there are no asymmetric information. Of course, for instance, as a dictator, if I know everybody's utility function, but if you do not know mine, that is a huge issue, right?
Yes, there is incomplete.
Yes, there is incomplete
Asymmetric
information. Exactly, there is asymmetric information. Then I can use my information set to do something better. Okay. If there, for instance, one of the goods are public goods, is a public good. Let's say education. I actually have one question. One of the final exams, I guess, I asked about the distribution of students across private schools and public schools, because now there are two different goods, right? One set of people have lower incomes, another set of people have higher incomes. So you might be envious if your kid goes to public school, and if private schools have higher qualities, etc. So there could be many interesting cases depending on the story, and of course in the exams you will see different stories. But understand the concepts. That's the requirement. Okay then. Thanks for showing up. Next week again we're gonna discuss the toy model. I'm gonna upload the videos as soon as possible. Okay. Today I'm a bit busy because I have 2 other lectures, but tomorrow or Friday I will upload them and I can put the links to the Huzem, and we're gonna go along. Okay?
Thank you for the lesson.
Okay, you're welcome. See you next week.
See you.
Have a nice day.
You too. Bye bye.